Hello everyone, welcome to In 5 Minutes. In this video we are going to see the next type in gamma function, that is type 3. But before that, the gamma of n is given by integration of 0 to infinity e raised to minus x raised to n minus 1 into dx. So this is the basic form of gamma of n, and we have to reduce any given equation in this form so that we can apply the property of gamma. So what is in type 3? In type 3 our equation will be something like this: integration of 0 to infinity e raised to minus ax x raised to n sine bx, or instead of sine it can be cos bx. So our equation will have a sine term or cos term. So we do not want this sine term and cos term. If you see here, we don't have any sine or cos term. We have e raised to term and we have x raised to term. We do not need sine and cos term. So what we are going to do? How to get rid of the sine and cos term? So if we know what is the formula of e raised to I times bx, what is the formula of e raised to I times bx? We know that whenever we have the complex term e raised to some complex term, we know that it is nothing but e raised to I bx is nothing but cos of bx plus I sine bx. So this is our e raised to I bx. So we all know e raised to complex, that is I bx, is nothing but cos bx plus I times sine bx. So if you see here, we have the terms matching: sine bx, cos bx. So if we have sine term in our equation, so sine term is the imaginary part. Okay, the sine term is imaginary part of e raised to I bx. So instead of sine bx, we are going to write imaginary part of e raised to I bx. When we have cos bx is the real part of e raised to I bx. So we write real part of e raised to I bx. So instead of sine and cos, we can write imaginary part of e raised to I bx. We can write real part of e raised to I bx. So this term will be replaced by e raised to I bx, and real and imaginary part we will write here. Then we will combine this e raised to term and this e raised to term. Then we will solve our problem. So this will be more clear when we see the problem on this type. So this is our question. Show that integration of 0 to infinity e raised to minus ax into x sine bx dx is nothing but this term. So this is our integration, and if you see here we have sine bx, so we can write as sine bx is nothing but imaginary part of e raised to I bx. So instead of sine bx we are going to write this term. So our I will become integration of 0 to infinity e raised to minus ax into this x, and instead of sine bx we are going to write imaginary part of e raised to I bx into dx. Imaginary part of something is we can take out of the integration. So we have imaginary part of this term. So imaginary part of integration of 0 to infinity, and we can combine this e raised to minus ax and e raised to I bx. So e raised to minus ax into e raised to I bx is nothing but e raised to minus ax plus I times bx. So from these two terms I am taking x common and I am taking negative sign also. So minus x I am taking common, so inside will be a minus I times b. Okay, so our these two terms will be nothing but e raised to minus a minus ib into x, and this x will remain as it is into dx.